Assalamualaikum warahmatullahi wabarakatuh and a very good morning to all students. So today I'm going to introduce you to a very important book. The title of the book is Fundamentals of Open Channel Flow. So in the next 7 weeks of studies, we are going to learn on this chapter together. So it's about open channel flow. So this is the textbook that I'm going to use in the lectures for this topic. So it's important for you to have this kind of reference. I always like to have a textbook when I learn about any new topics. It's very important because you can know um, about this topic in general, and if because in the lecture we are not going to study all chapters, we will study only on the topics which are related to the syllabus. Okay, and what I'm going to share with you during the lecture is the simplified version from the textbook. So if you want to know every detail, you can always refer to the textbook. Because I also refer to the textbook and you must also refer to the textbook. Okay, so this textbook is written by Mr. Glenn E. Moglen. So, and it's published by CRC Press. The year of publication is quite recent for this textbook, is in 2015. Yeah, and we are lucky because we have this e-book, so we don't have to carry the textbook around like what I used to do in the 15 years ago. Yeah, it's nice. If you're interested to focus on to have the hard copy, you can always print the topics that you want. Yeah, you don't have to have the bundle of it. You can have a very thin and you can bring it anywhere and you can read, highlight and write something on the text. Okay, let's see the contents. So this is the contents of the textbook. If I'm not mistaken, there are 8 chapters, maybe 7 chapters in this book. Yes, 7 chapters in this book. We are only going to learn the topics which are included in the syllabus. Okay, so please have a look, and you can have already a general idea, and before each class you can read by yourself. It's really interesting when you read this textbook because it's quite easy to understand and you can imagine when the author explain you something, you can easily imagine them, of course with the help of figures. Okay, so now we move on. Okay, you can also see a preface here. I always like to read the preface before I read any books, even storybooks or textbooks, because we can know the intention of the author when he wrote this book. What was his intention? So by knowing his intention, actually we can also like um, understand. We feel more enjoy. Sometimes we can relate, yeah, to his intention because we want to learn, and he wrote the book to teach us. Okay, so you can read this later. Okay, and this is the reference for him when he wrote this book. This is Henderson. Actually, Mr. Henderson FM is the teacher for Glenn Moglen, the one who wrote this book. Okay, so now today we are going to look at chapter 1. This is the introductory material. So before we go further, before we go in depth, it's good if we can have we read this chapter together. Okay, so for this chapter, the objectives, there are 5 objectives for this chapter. First, to define open channel flow, define basic quantities relevant to open channel flow, present and discuss fundamental governing equation. Number 4, to identify different classes of open channel flow problems. And finally, to emphasize the value and importance of critical thinking. Okay, for the introduction, what is open channel flow? Let's read together. As used in this text, the term open channel flow covers the range of natural and artificial conveyances of water in settings that are open to atmospheric pressure. Some examples of open channels include water flowing in creeks and rivers through irrigation canals, within open air conveyances, in wastewater treatment plants, and along the curb and gutter edges of streets and parking lots. The channel, therefore, varies from a natural surface lined with naturally occurring sediment to a man-made surface made of concrete, metal, or graded soil and sediment. So anything that you can imagine. Okay, you just observe your surrounding and you can see open channel flow. The easiest is the drain, right, behind your house, next to your house, in front of your house. Okay, to properly study open channel flow, so this is the yellow one, I read. To properly study open channel flow, we need first to define the basic quantities that are at the heart of the physical system, to enumerate the most fundamental governing equations, and to develop a classification system for different kinds of problem that will be addressed. Okay, these items are discussed in this chapter. Okay. Okay, let's see. So first, the quantification of open channel flow. Let's see figure 1. Okay, this one figure 1. So this is open channel flow. You can see this is the water surface with the depth of y. Y is from the water surface to the bottom of the channel. Okay, and then we have z. Z is from the bottom of the channel to the datum. Okay, so this is the bottom, the channel bottom. So there is also a slope here, which is determined by the angle of the slope. Okay, so this is the basic profile view of open channel flow quantities. Okay, let's read. The flow depth is arguably the most important quantity when approaching problems in open channel flow. Remember this, yeah? So you will see this a lot when you deal with open channel flow. Depth is measured in the vertical plane from channel bottom to the water surface. Okay, so next we have channel slope. Okay, and then this is the angle of the channel slope. Okay, and then we also have quantity of Z. Okay, the horizontal datum. Okay, so next, the flow velocity is also the primary importance to solve open channel flow problems. In reality, velocity varies in the vertical form, essentially zero at the channel bottom to generally a maximum value at or near the water surface. So velocity from here, it says that it's essentially zero at the channel bottom, but maximum at the water surface. Okay. Velocity also varies across the width of the channel in potentially very complex way depending upon the channel shape. In this text, however, we rarely consider this variation. Okay. Instead, we work with a single aggregate value of velocity that represent a mean value across both the depth and width of the channel cross-section. Okay. So you can always imagine about this. When you see a flow in a channel, open channel, the velocity is actually varies along the flow, but for the sake of calculation to solve any problems, we'll take an average value of V. Yeah? And then you must know that why the depth is very important. Okay, let's see. This is figure 1.2. This present a cross-sectional view of flow in an open channel. So this is totally different than pipe flow, because in pipe flow you always have circular or maybe rectangular pipe, but normally only circular pipe, but the A is fixed, right? Because we consider that the flow is full in the pipe. But in the open channel, you can have many different types, many different shapes of open channel. Okay, so you have Q, and Q always relate with A, and air always relate with y, the depth of the flow. Okay, okay, let's read here in the pink color. In a closed conduit such as a pipe, assumed to be flowing full, like I said just now, the cross-sectional area is fixed and constant. Thus, the physics of the flow are constrained largely to understanding the flow velocity, issues of friction, and the total of energy possessed by the flow. Okay, however, now you see this yellow highlighted. In open channel flow, the depth plays a dual role. First, it controls the energy possessed by the flow, and secondly, it determines the cross-sectional area of the flowing problem. Okay, this is the challenge of solving open channel flow problems, and it is also the beauty of solving such problem. Okay, although it should be understood by the reader that the natural world offers an endless range of possible channel shapes. Like I told you just now, there are many types of different shapes of channel flow, open channel flow. But in this book, the emphasis is placed on rectangular channels, not because they are widely used, but because the mathematics of flow in a rectangular channel are as simple as possible and allow the reader to focus attention on other more pressing open channel flow phenomena. Okay, like V, the discharge is also varies along the channel, but we treat Q as you take the average in order for us to solve the problem in open channel. Okay. There are also other parameters which are fundamental in solving open channel problems, like water density. Okay, you already know this, and also unit weight of water. Also viscosity, which are kinematic viscosity and also dynamic viscosity. Okay. Okay, let's move on to the foundational equations. So there are only 4 foundational equations that quantify the concept of continuity, concept of energy, momentum, and friction. So only these 4 foundational equations that we are going to see for this topic. Okay, also, of course, you also have to deal with Bernoulli energy equation. Okay, yeah, you are already familiar with this continuity and Bernoulli energy equations, and you are going to see also Froude number. Okay, so we are going to look at this in detail after this. Okay, when we learn about open flow channel. Okay, now we look at the classes of problems. So we classify the flow according to we could classify them so that it's easier for us to solve the problem. Yeah. First, we have steady state flow. Steady state flow is the flow which is not changing as a function of time. So we call it steady state. But if it's changing as a function of time, then we call it unsteady or transient flow. Okay, next we have uniform flow. Refers to the condition of flow changing as a function of space or position along the channel. But we also will deal with non-uniform flow, with is changing as a function of space and position. So we will look at this in these open channel problems. Okay. Okay, finally for this chapter, the need for critical thinking. So it's like this critical thinking is very important, and the author wrote here what are the critical, how can we have what kind of critical thinking that are needed in this open channel flow. Okay, you can read this. Okay, I think that's all for this video. Please have a look at this textbook and enjoy it. I think this is a very helpful material for us. I learned from this book, and you guys also learn from this book, and we learn together. Okay, it's always nice to have the same reference. Yeah. Okay, I'll see you in the next video. Thank you so much. Bye.